Hello, Algebra 2. Today we're going to be looking at the graphs of the tangent, cotangent, cosecant, and secant functions. For this video lesson though, we're going to be focusing on the tangent function. So let's recall a couple of things about the tangent function that you never want to forget. First, the tangent function has a period of pi. Second, the tangent function is undefined at blank. Let's figure out that. If you remember, tangent of x, you can always rewrite that as sine of x over cosine of x. And then to figure out where tangent is undefined, you want to ask yourself what makes cosine of x equal to 0. Because anytime you have a fraction, right, you can't have a 0 in the bottom. So if you remember, cosine of x equals 0 when your angle corresponds to either this point or this point on the unit circle, because cosine of an angle whose terminal side lies on the y-axis would correspond to the x-coordinate of that point. So if you think of all the angles whose terminal side lies on the y-axis, they would all just be odd multiples of pi over 2. If you mentally visualize drawing these angles in standard position, you'll see how each of those angles have a terminal side that's on the y-axis, right? They're quadrantal angles. And so cosine of all of those angles will just be 0. And so those are the values for which tangent is undefined. Lastly, the tangent function is an odd function, which means that it has symmetry with respect to the origin, and we're going to be using these facts to graph the tangent graph. So because the period of tangent is pi, what we're going to do is we're going to graph our tangent function in this interval here, between negative pi halves and pi halves. And so to do that, what we're going to do is we're going to fill out a chart. So first thing to note is that pi over 2 is approximately 1.57. What we're going to first do is plug in a couple of values that we should know how to find. So tangent of 0 is just 0. Tangent of pi over 6 is root 3 over 3. This is approximately 0.58. Tangent of pi over 4 is just 1. Tangent of pi over 3 is square root of 3, which for graphing purposes will be approximately 1.73. I want you guys to get your calculators out and find tangent of these 5 angles here. And if you notice, these angles are getting closer and closer to pi over 2. What we're going to do is take a look at how the tangent function behaves as the values of x are getting closer and closer to pi over 2. So take out your calculators, work these out, and then when you're ready, press play. So the first thing I hope you did was check what mode your calculator is in. Is it in degrees or is it in radians? Here you want to make sure you're in radian mode. So if you did tangent of 1.4, you should have got about 5.8. Tangent of 1.5 is about 14.1. Tangent of 1.55 is about 48.08. Tangent of 1.57 is 1,255.77, which is pretty crazy if you think about that. Just by moving x over 0.02 units, look how much it jumped. Now when you plug the 1.5707, just by moving 0.0007 over, you should have got something around 10,381.33. So what you notice is that as x gets closer and closer to pi over 2 from the left-hand side, the tangent function gets bigger and bigger, right? We say it approaches infinity. So a lot of times the notation that we'll see, maybe in pre-calculus next year and in calculus, is we can see something like as x approaches pi over 2 from the left-hand side, that's what that negative means. It indicates you're coming from the left-hand side. We can say that tangent of x is approaching infinity, right? It's getting bigger and bigger in the positive direction. So what we notice from this is that we're going to actually have a vertical asymptote at pi over 2. Tangent of x is going to keep growing without bound. It's going to be getting closer to the vertical line, but it's never going to intersect it. So what we're going to do now is just plot the points that we have. 0, 0. At pi over 6 is approximately 0.58. at pi over 4, which is right in between pi over 6 and pi thirds, you get 1. For pi over 3, it's about 1.73. And then from there, we're going to connect our dots. We're going to graph the left half of this tangent graph by using the fact that there's symmetry with respect to the origin. So all I'm going to do is I'm going to take each of the points I just plotted, but just take the opposite of the x and the y coordinates. So for negative pi over 6, I'm going to plot the point negative 0.58. For negative pi over 4, it's going to be negative 1. For negative pi thirds, it's going to be negative 1.73. And I know that I'm also going to have a vertical asymptote at negative pi over 2. Connecting our dots, you'll get a graph that looks something like this. And so this is our tangent graph. It almost looks like an x cubed graph, right? And that's kind of one way I remember this. Now when I graph a tangent graph, I'm usually going to plot not this many points, right? Because I think we plotted 7 points. Whenever I graph the tangent function, I'm always going to plug in this point here. I'm always going to plug in this point here, which is at pi over 4, which is right in between 0 and pi over 2. Then I'm going to always plug in a point at negative pi over 4, and that'll give me negative 1. So usually those are going to be the 3 points I plot when I graph a tangent graph, as well as the asymptotes, okay? So just keep in mind that I only graphed one period right here. And if you notice, this is a period of pi. And the rest of the graph of tangent will just be duplicates of this. So if you look at the tangent graph, it'll actually look something like this. You notice that I have vertical asymptotes here at odd multiples of pi over 2. And so we're going to look at some of the properties of this tangent function. The domain in this case is all real numbers except where the vertical asymptotes are. And if you remember, the vertical asymptotes occur at odd multiples of pi over 2. And so I can just say that the domain is all real numbers except odd multiples of pi over 2. And then the range, if you notice, will be all real numbers. We talked about how the tangent function has a period of pi, and that is periodic, right? It keeps repeating every interval of pi length. We know that the function is odd. We talked about how it has symmetry with respect to the origin, and that's how we graph the left half of the tangent function. And we notice that the x-intercepts occur here, and if you notice, they're just at multiples of pi. So your x-intercepts would be at negative 2 pi, negative pi, 0, pi, 2 pi, and so on. The vertical asymptotes will occur where the tangent graph is undefined. Right, so again, tangent is sine of x over cosine of x. So ask yourself, what makes cosine of x 0? Those are where your vertical asymptotes will be. So I know that cosine of negative 3 pi over 2 is 0. Cosine of negative pi over 2 is 0, so on and so forth. Odd multiples of pi over 2. And so what we're going to do is we're going to look at a couple of examples where we graph the tangent graph. When you graph the tangent function, it's so important that you get the asymptotes correct, because if your asymptotes are wrong, your whole graph is going to be wrong. So let's look at a couple of examples here. So starting with this first example, we have y equals 3 tangent of x minus pi over 2. The way I'm going to do this is by graphing it using transformations. So I'm going to first start off by graphing y equals tangent of x. And so in this case, we know that the asymptotes are at negative pi halves and pi halves. I'm going to put 1 here and negative 1. And so my tangent graph, I'm going to plot 3 points. The first point will be at negative 1. The next point will be at the origin. And then the next point will be at positive 1. And so this will be the graph of my tangent function. something like that. Now from there, I'm going to upgraph my next function, which is going to be tangent of x minus pi over 2. If you remember, this is a horizontal shift, and with horizontal shifts, they never tell you the truth. So when you see x minus pi over 2, don't think left pi over 2 because that's what we're naturally inclined to think. Think right pi over 2, right? And so if we take this graph and we move it right pi over 2 units, all we're really doing is we're adding pi over 2 to every single x coordinate on the graph of the tangent function. And this also means that my vertical asymptotes will also move. My asymptote was originally at negative pi over 2. If I move that to the right pi over 2 units, then my vertical asymptote will now be at 0. And then if I take the vertical asymptote at pi over 2 and I move that to the right pi over 2 units, that will move over to pi. And then from there, I can just take those points, those 3 points, plot them out, and it'll look something like this. The last thing I want to do now is graph it with the 3 in the front. If you remember, that's just a vertical stretch by a factor of 3, which just means all we're doing is we're multiplying all the y coordinates by 3. So if I multiply this point right here by 3, I'll get negative 3. And if I multiply this point right here by 3, then I'll get positive 3. I'll still have a point right here, right? Because 0 times 3 is 0. And then when you graph it, you'll get something like this. So hopefully you see how we graph that. Ultimately, when you're graphing these, always make sure you get your asymptotes correct, because if those are wrong, then everything else is going to be wrong, okay? So at this point, I want you to try number 2 on your own. As usual, do your best, and when you're ready, press play. So for this one, I'm going to start off by graphing y equals tangent of x, which again, those are asymptotes at negative pi over 2 and pi over 2. And I'm going to plot 1 here. I'm going to plot 1 here and negative 1. This is not drawn to scale. And then from there, I know that with tangent, I have 3 points. And I can just connect them like this. Now from there, we're going to move on to y equals tangent of 2x. In this case, that 2 on the inside is going to affect it horizontally. And what you're going to do is, again, you're going to think the opposite of what you would be inclined to do. We're not going to multiply the x coordinates by 2. We're going to divide the x coordinates by 2. So it's actually going to shrink. So what that means then is that if I take one of my asymptotes, which is at pi over 2, let's say, if I divide that by 2, then I'll get pi over 4. And that's going to be my new asymptote. Similarly, if I take my other vertical asymptote, which is at negative pi over 2, if I divide that by 2, I get negative pi over 4. And so that means that my new asymptote will be at negative pi over 4. So let me just label this real quick. So now plotting our points, my first point here will be at negative 1. My next point will be at the origin. And then my next point would be here at positive 1. And then I'm going to connect the dots. And then you should get something like this. Lastly, we're going to be graphing y equals negative 1/2 tangent of 2x. Now here, if you notice, there's 2 transformations that are taking place, right? There's a negative, which is a reflection across the x-axis. And that 1/2 is going to shrink it vertically by a factor of 1/2. In other words, you're just going to be taking all the y coordinates and multiplying it by 1/2. So now take the graph of tangent of 2x, right, the pink curve, reflect it across the x-axis, and then multiply all the y coordinates by 1/2. Do you see how the first point here would be right there? The next point would be here at the origin still. And the last point would be here at negative 1/2. And then from there you can connect your points. And that would be the graph of y equals negative 1/2 of tangent of 2x. If you note here, this graph has a period of pi over 2. Right, if you look at the distance between negative pi over 4 and pi over 4, that spans a distance of pi over 2. Tangent normally has a period of pi, right? It takes an interval of length pi for one cycle to be completed. But because of this 2 right here in the function, that shrinks everything horizontally by a factor of 2, which means that one cycle will be completed in half the length that it normally would. And so the period here is pi over 2. So guys, make sure you understand where these vertical asymptotes came from. It's where cosine of x was equal to 0, right? Because tangent of x is sine of x over cosine of x. Make sure you understand how we graph the curve. If you notice, it resembles an x cubed graph. And then make sure you understand the transformations and how that could affect the asymptotes as well as the graph itself. So guys, review this material. Make sure you understand this before you watch the next video lesson.